All right, these are the solutions to the Batmobile problem. And this one is, I tried to make it realistic. Sometimes the speed of the football and the angle, because that makes the most sense of how you would know that information. But in the real Joker and Batmobile demo, you would probably know the speed of the Batmobile separately from the speed at which the Joker was ejected. So we've already broken down the Vx and the Vy separately. You don't need to do the sine and cosine. All right, so that's its horizontal speed. When it ejects a Joker with the vertical speed, calculate the time at which the Joker lands back in the Batmobile. So remember the video we saw with the dude on the boat, and he dropped the balls from different when he was in the boat, even though it looks like the Joker only has this Vy, he's in the Batmobile, so he also has the Vx. All right, so let's set up but then you want to think about, is time going to come from my horizontal Sudoku or my vertical Sudoku? We don't know where the Batmobile and therefore the Joker are horizontally, but we do know it's landed back in the Batmobile. So we're going to call that, like hitting the backfield, right? We're essentially calling, the level of the car the ground. Okay, so that is landing back in the Batmobile is saying that Y final is 0. So that is my vertical Sudoku. So it started on the ground and it ended on the ground. Okay, and hopefully you've done enough of those football problems that's really comfortable to you. That starts on the ground, ends on the ground. V naught in the Y direction is 3.75. Acceleration is negative 9.8, and we're looking for time. So we know more about the position because this row is complete. So we're going to say y equals y naught plus v naught t plus at squared over 2. I end on the ground. That's the output of my function at the time I care about. I started on the ground. I did have a head start. I was launched upward because I stole Batman's car. And I'm on Earth, so gravity's pulling me down. Okay, and then you don't have to do quad here because the C term is 0, but it's pretty easy to plug in the quad and you get one time is 0 because we knew that already, just confirming that it was at that height at t equals 0 when it was launched, and the second time is 0.765 seconds. Sorry, that's t equals 0. Quad t equals that size. Okay, how far horizontally the Batmobile has traveled. So that's the horizontal position function. No acceleration because it's horizontal. And they started at 0. They had an initial speed of 5.12 meters per second. And remember, time passes evenly for both. That's why in the animated lab, right, your times were the same for both your horizontal and vertical data points. And you get that. That's huge. That's like the height of the atrium. So I gave the Batmobile too much speed. But that is where both the Joker and the Batmobile are, right? That's the whole point of the demo, is that the Joker and the Batmobile both have this horizontal speed. So the Joker is always directly over the Batmobile. And then the max height of the Joker. So max height sounds an awful lot like it's about location, but it is about saying I have no vertical velocity for a split second. So we're going to look at our velocity function. And we want to set the output to 0. The initial vertical velocity was the 3.75 meters per second, and we're solving for time. So don't plug in the time that you found above. Let's see, subtract 3.75 from both sides. So you get minus 3.75 equals minus 9.8 t. Divide both sides by negative 9.8, which is good because then we're going to get a positive time. And we get a time of 0.383 seconds. Okay, but that's not the final answer. We kind of care what time it happened, but what we really want to know is how high did the Joker go? So that means we care about its location. And so now we'll take that time and plug it into the position function. Started on what we're calling the ground, which is the Batmobile, with an initial speed of 3.75 minus 4.9 t squared over 2. And I did, sorry, minus 4.9 because 9.8 over 2 is 4.9. Okay, sorry, that's on one line. And you get 0.717 meters. That is how high the Joker is, the max height. If you had extra time on a test and you wanted to check your work, you could plug in a time a little bit before that. You could plug in t equals 0.36 or a little bit more than that, t equals 0.4, and your height should be less than 0.717. Okay, so if you're like, I want to check my work and I clearly can't look at in the back of the book for the answers, sorry about that. That would be one thing you could do. All right, that is the Batmobile and Joker demo problem, and hope that went well for you.